So hello guys, so today's question, basically I'm solving the question from the blind 75 sheet. Okay, so the next question from that sheet is search in rotated sorted array. Okay, so what this question is saying, that we have to search the number, that is basically we have given here target value. Okay, we have to search the target value in the this rotated sorted array. Okay, so the question is straightforward. If you don't know what is rotated sorted array, and the main thing here written is that you must write an algorithm with big O of logn. Okay, we will see that later. Okay, so if the number is present, then simply we have to return the index, and if it is not, then simply we will give -1, okay, as the result. So let's check what is rotated sorted array. So here's the explanation of this thing. What is rotated sorted array? So I have given the two array. Okay, this is sorted array and this is a rotated sorted array. So what's the difference between them? If you see that in this sorted array, the all elements are sorted, and this rotated sorted array, what is there? Okay, so this was the first sorted array. Okay, if we do first rotation, that is basically from previous, the 7 will come forward. This is rotation, like if we take a circular thing. Okay, so if we see, take it as a circle, then simply 7 will come forward. Okay, it will simply rotate itself, then 7 will come forward. For in second rotation, 6 will come forward, and this whole thing is sorted now also. Okay, if we see in rotation type. Okay, so in third rotation, it will simply 5 will come forward, and then fourth rotation 4 will come forward. Then if you see this, in after fourth rotation, we have got this, that we have given the input. Okay, so you got the thing that this is a rotated sorted array. Okay, the sorted array is rotated 4 times, and then this array has come. So it's not given in the question that how many times the sorted rotation is done. We have to simply find the integer. Okay, find the integer in the rotated sorted array. So you go, let's do the approach. Let's go on the approach. Then how will do this question? How will we find the integer in the rotated sorted array? Okay, if there was a sorted array, then it was so simple, but it is a rotated sorted array. So let's check how we'll do it. So the first approach that we're gonna see it is basically simply brute force. Okay, so it is simply a linear search in which I have this target value is given. That is basically what we have to find. What we will do is we will simply iterate through this array. Okay, we'll simply iterate through this array and check if this number is equals to the target or not. If the number is equal to target, we will simply return the index of that number and we will break out from the loop. So what would be the like? This is the simple code for this linear search. Okay, it will simply search in whole array. So basically this is not the best approach. Why? Because its time complexity is big of n. Okay, big of n. And if we go on the question, it's simply written we have to write an algorithm with big O of logn, and this question comes in medium. Okay, medium. Okay, so if it's the answer is this, like if we use linear search, then it will simply be an easy solution. Okay, we don't have to do it. It is simply written that we have to do it in big of logn. So we should use a optimal approach, or we can simply optimize our approach. That is, we can use simply, how can we do it? We can simply use a binary search. Okay, a binary search do this thing, this linear search in binary search is the upgraded version of the linear search. Okay, it simply eliminates the part which we don't want to use. Okay, so let's check the next solution, that is binary search. So if we see what is binary search, so we are taking a sorted array. First I will explain you what is binary search, then we will move forward to the question that we have given. Okay, so in binary search, it was simply what the binary search is. We simply do that we take two variables, that is low and high. Okay, and we will simply take a mid value. Mid value is equals to the low plus high and divided by 2, basically the middle value of low and plus high. Okay, so if we see in this question, first if we see in this, what is the mid will be here. Okay, at 4, mid will be here simply. Okay, so this is how the it works. Mid will be here. If we have to find, basically let's check, let's take a target value as 2. Okay, we have to find the 2 in this. Okay, I am just explaining what is binary search. Okay, then we will move to the main question. Okay, so let's check the mid. Okay, so this is mid. Mid will be here at 4. Okay, so is mid equals to our target? Okay, no. Then we will simply check. So if we see that mid is not equals to the target, okay, so this array is sorted. So simply if we apply the logic, that simply our answer is as target value is lower than, okay, we will check if the target is lower than mid or higher than mid. If it is lower than mid, simply the value will be between the low and mid, and simply this, if I take this whole part, will be eliminated. Okay, or if I correct it, this whole part of, basically this whole part will be eliminated. Okay, so the answer would be only in this. So then simply what we will do is we will check is our target is lower than mid or higher than mid. If our target is 2, simply it is lower than mid, then simply we will move high to here, mid -1. Okay, so our new mid would be, then we will again calculate mid. New mid will be 0 plus 2 upon mid 2, that is basically 1. So mid will be at 1. Okay, so if we see that our mid will be at 1, so then it will again check is the mid is the target is greater than or smaller than mid. Okay, so simply the target is greater than mid, so it will simply go that low would move here. Okay, because if the target is greater than mid, if the target is greater than mid, we don't want this area, or I can, if I draw, we don't want this area. Okay, this whole part is gone and this whole part is gone at second. Then simply we will move this low to this high. Okay, then okay, for the again, basically we can calculate mid. Okay, or the condition that we will check, this whole thing will we work in if till the low is smaller than or equals to high. Okay, then simply we will return the value of mid, and okay, mid will be low plus high by 2. The thing, this whole loop will work till while low is smaller than or equals to high. Okay, you got the thing, and we will simply return the answer at mid. Okay, we will simply return that mid if the mid equals to the target or not. So this is the answer. This is the approach of binary search. So you got the binary search. Okay, this is how the binary search works. Okay, we will simply use this binary search approach in our question. Okay, so you got the approach of binary search. Okay, so we are taking the example for our now main question, that was basically search in a rotated sorted array. So this is the rotated sorted array. How this binary search will help us in finding the solution for this question. Okay, so let's check. Okay, we will take two variables, that is low and high. Let's keep it from here. This is low, this will be high, and we will calculate mid from for every value. Okay, mid is, sub formula is this low plus high upon mid 2. Okay, So for first, let's check what will the mid. So let's just write here indexes 0. So I've written the indexes. So let's check what will the mid value for this. It will be here 0 plus 6 upon 2 will be here 3. Okay, mid will be here. So let's do what we'll do that. We will simply check if is the mid smaller than, basically is the target smaller than mid or higher than mid. That we check in this binary approach, binary search that we have done earlier. Okay, then it will simply see that it is the smaller. Then we will do is we will simply cut this thing, that our answer would not be here. Okay, but not this, we will not do here. Okay, what we will do here is that we can't do this because our answer, if we see the answer is here. Okay, so in this approach what we will do is we will simply check, we will check for the sorted half. Okay, if we see here, okay, if we see here, this is our rotated, this is our sorted half. Okay, this is a left sorted half and this is a right sorted half. So how will we find it? Okay, simply when our mid will be here, okay, when our mid would be here, we will simply check. What we will check, let me write. Okay, if array of low, that is array of low, that is basically at this index, is this smaller than or equals to array of mid. Okay, this condition will simply check if this is okay, if this is fine, this check is fine, basically if this check is true, then simply we will get that our left part is sorted. This is the left part, left sorted. Okay, we will get the left part is sorted. Okay, let me check the spelling. Left part, left sorted. Okay, we will check. Then in this left part we will check again if the number at, if this target lies between the low and mid. Okay, array low is smaller than or equals to target, and array target is smaller than equals to array mid. If this is checked, basically if this is true, then we can see that our target lies between the low and mid. Okay, our target is between the 4 to 7. Okay, so here we can see this is not the case. Our target is not between here low and mid. Then we will simply, in this case, if this is true, okay, if this is true, then what we will do is our target is between this low and mid, then simply we will move high to this mid minus 1. High equals to mid minus 1. Okay, and if it is not, at else part we will simply move low equals to mid plus 1. Okay, for this case we can simply say that this low would move to this because our answer lies between our answer is not between this low and mid where the low was. Okay, this our answer is not with this half. Okay, we'll simply move here. Okay, so next we have to calculate the mid. So the mid would be simply here. Okay, the mid would be simply here at 1. Then again it will simply check, is the that's again this condition, is the array lower than mid? Yes, then simply we can say we are in the left sorted part, that is 0 1. And then again we will simply check this condition, second condition this was, and if the array low, basically this 0 is smaller than target, that is true. Yes. Okay, and is the target smaller than the array of mid? No, the target is basically larger. Okay, so again this condition will not work, and again it will simply come in low equals to mid plus 1. Then low will come here. Okay, simply low will come here. Okay, if the low come here, then simply our main loop, that is while low smaller than equals to high, will terminate. Okay, the low becomes equals to high, and we can simply check here, or we can simply, this condition will check in between this loop. If any is any time, then simply we can simply return this. Okay, in this, the mid is at low plus high upon mid 2, so the mid will also be 2, so simply it will return the target value, and this loop will exit because low becomes the equals to high. Okay, it will simply work for the low equals to high anytime. Okay, uh, okay, and simply we will calculate mid, and then again this will not work, and the low or high will become, low will surpass the high, then simply the loop will terminate. Okay, so this was the whole approach. How will this whole thing work? And this is the first this loop is for this if condition for is for the left sorted array. Simply we can write, if the answer is present in our right sorted part, then we can simply write for the right sorted part, if array of high, if this part was sorted, we can simply say our answer is between this part. Okay, mid to high. If the low was not basically this low was lower, so simply we get in the first loop. If the low mid was here, then simply we would get in the second, basically in the second condition, that is array of high is greater than or equals to array of mid. So I will provide you the code for this binary search, and this is the most optimized version. Or if you see time complexity, then simply the time complexity for this is big of log n. So that's the question was demanding. Okay, so here's the basically code. I hope on the LeetCode. So we have taken the two variables, that is low and high, high on the last index and low in the first index. We will simply use this loop till low is smaller than or equals to high. We will calculate mid at every point, and if at any point nums mid equals to the target, we will simply return mid. Then if then we will simply, this is for the left sorted part, and this is for the second right sorted part. Okay, for left sorted part, we will simply check if the number at the lowest point position is smaller than mid, then simply it is the lowest left sorted part. Okay, it is we will find out the it is the left sorted part, and we will simply check if the number is low, nums low is smaller than the target. Okay, and the target is smaller than the nums mid, basically mid between the low and mid. And if it is there, simply we will move high to mid minus 1, and we will eliminate the whole part beyond the mid. Okay, if it is not there, we will simply got the answer that it is not in the left sorted part. We will simply move the low to mid plus 1, we will move to the right part. Okay, and else condition, it will simply the else condition is for if the number is in the right sorted part. Basically it is for the right sorted part. We will simply check if the number is in basically between the mid and the high value, basically between the right sorted part. If it is there, simply we will eliminate the left part. If it is not there, we will simply eliminate the right part. And at last, if it the loop terminates and we find nothing, then we will simply return -1. And you can see if we run or submit the code, it was simply like if, and yes, the runtime is 0 ms and beats 100% of the case. Okay,